Okay, check, mic check 1 2, great. I'm gonna do another automate your network video. I definitely think doing the LPIC makes sense, but I'm just having fun, so I'm gonna continue to have fun. Um, Last video, I actually did something really interesting. I um, talked to the AI about how to build a network, and I actually ended up building out my virtual lab in doing so. Now, the AI, if you've really gotten into in-depth conversations, you can tell that okay, we're just not there yet with AI. It's not perfect. One of the things you can do is you can play chess against the AI. So I can do this right now. Um, let's play a game of chess. Set up the chessboard and make the first move. It can't do this.
I'd be happy to play a game of chess with you. Since you're working on your major goals like mastering network automation and preparing for the NCORE and LPIC1 exams, playing chess.
Okay, so I'll start with the classic move. E1. Okay, well I want to go to Z14. Yeah, it's not a valid. Yep. So yeah, let's do E5. See, the thing is like this is what I'm getting at. Is like it's not going to respond. Um, like if you actually had a chessboard out and you were like mapping out these moves, like eventually it'll start to make mistakes. So like chess board, um like let's see if I can just get like a virtual chessboard, um where I can just move the pieces as I want. Yeah, like a chessboard editor. Yeah, so this looks good. So let's play chess against the AI, and I'll hopefully this won't take long, and I'll just demonstrate. So they're white, and they went with E4. So they moved here. All right, and then I decided to move to E5. All right. So now they're gonna play the knight to F3. Um, okay. So C D E F. There we go. All right. So now I'm gonna move to E6. Yeah. So like, oh, sorry. I actually meant to say D6. Okay. It's actually kind of doing better than I thought, but one of the things you can do is like have it um so now they're going to play D4. All right. So I'll do bishop to I'm not that good at chess. I'll do a knight to I'll do a K F6. Oh, whoops. I guess I'm bad at this. So they're playing a bishop to uh, G5. Yeah, see, here's the thing. Like, I played this to KF6. So, A, B, C, D, E, F. Yeah, this is what I did, KF6. And already it's starting to break down. um, they think that they put me in check, but my knight is in f6. You did not put me in check. My knight is in f6. See what I mean? So like it doesn't, like it forgot that I moved it to f6. So they can't play there. So I'll let them take their move back. And it's going to play uh so NX, I'm not sure what that is, but to E5. See, and this is a thing too. Like it's unclear about what this is. Like, is this? I don't think this is like actual chess notation anymore. It's just like putting random characters in there that don't belong. So yeah, and then see, it tried to do the same thing that it did up here, but it thought it could get away with it just by, you know. So now we're gonna do E5 again. There is no move in e5. I have a piece in e5. So yeah, this is a perfect demonstration, and it didn't take that long. So like, see what I mean? Like it can't, like it can't see something through from beginning to end in a way that requires like large amounts of like things, like it can't basically like take checkpoints and like refer back to checkpoints of things that happen. So like that's something humans could do. Like we can play chess, and then we can like remember the moves that were made, or just like visually represent them on the board. We can set up a board, we can abide by the rules of the board, we can decide whether to play, we can decide what board we want to use, we can make up special rules just for this one instance of our game. The AI can't do any of that. It can't even play a game of chess with you because it doesn't understand, like it doesn't, it's a large language model. It's like a glorified autocomplete. So it's just saying, given the current position, I'll play, and then it's just completing in based on its algorithm. It's not actually playing chess with you. It's not like remembering the last moves. It's not like looking for the best move. It's just trying to construct language, and although it's successfully doing this, all of this is grammatically correct. There's really nothing wrong with the grammar, with the spelling, with anything like that. It's not abiding by the rules of the game. It's making an illegal move and not realizing it because it's not a conscious being. You can't do that with the AI, but you can do that with other humans. So that's just one thing I wanted to point out because I think that's pretty interesting. So the next thing I want to do is go to back to the book and just keep reading through the book. So the next section is WASL and DRVFS. So Microsoft WASL and DRVFS can be used to set the permissions using traditional Linux change mod commands. If errors are encountered when running Ansible playbooks in Windows, particularly because the ansible.cfg file has world write permissions, use the following instructions to open change mod capabilities in Ubuntu. So first, unmount the drive. So I'm not using WASL. I have a lab here, and I'm using my basically like jump server in the lab. I'm basically simulating it as if like I were working from home. So I have this connected to my LAN network, and then I'm going in. So we're like presupposing that the network's all the way like set up already. So if I were working from home, I would be accessing the network through a like an ISP connection, and then my WAN between the data centers. And this is another thing they screwed up on in the AI. So like my WAN would probably look like something like this. Maybe that's accurate. Um, I don't know. And then like, I would plug into the WAN. I'm not sure that the WAN would look like this, but this, as I showed, like the AI is far from perfect. If we think this thing's gonna destroy humanity, or like, yeah, it's rapidly getting better, but it rapidly got better to be as good as it is. And how good is it really? Okay, so basically what I'm saying is, like, I'm just not sure. Like, as impressive as it has been, like, it's still failing to do things that have, like, it's still acting how AIs used to act before this was released. Like 5-10 years ago, we were not as impressed with AI as we are now, and I believe a lot of that reason is because AIs didn't do the critical, most important things we would need to be impressed by an AI, and I think that's, for me at least, still the case. If it could play a whole game of chess with me, just like this, and like set up the board and all that, I would be really impressed by that. But as it is, it's just like you're using it, and after a while, it's like this thing's like not very smart. Like, it can puke up and regurgitate things like a parrot, a stochastic parrot. I've heard that said before, but it's not thinking. All right, so this is what we do if we're running it in WASL and DRFS. We first unmount the drive, then we'd remount the drive, including the metadata, and then we'd set the permissions on the repo. So you can refer to the blog for more details about WASL and DRFS. I'm not sure what DFRFS is. I'm not doing that. Ansible playbooks can now be executed from the Windows 10 machine. So that's kind of cool. You can do it from a Windows 10 machine. I'm not doing that. I'm just using this Ubuntu machine in my lab. So next part is on Ansible. Ansible is the automation engine where playbooks are run either in check mode or full execution mode. Running playbooks is as simple as creating a YAML file and running the Ansible-playbook command in the Linux host. The syntax for Ansible-playbook is as followed. Ansible-playbook, and then the playbook name has got to be YAML, and then some options. So here's some common options: ask-vault-pass, which asks for the vault password, -C or -check. Do not make, so this is check mode. We read all about that. Check mode is wonderful. Do not make changes. Instead, try to predict some of the changes that occur. Man, I wonder how that'll go. And then this is -D, which is -diff. This is another thing we read about earlier. So when changing small files and templates, show the differences in those changes. Works great with -check. Then -L, capital subset, all in capital letters, subset, or -limit equals subset in capital letters. So this is further limit selected hosts to an additional pattern. So I guess you would fill in subset with the pattern you want. And then start at task equals start at task. So start the playbook at the task matching this name. So you got to fill this in with the name of the task you want to match. Then -step, one step at a time. Confirm each task before running. That's probably a good one to do. And then -s syntax check. Perform a syntax check on the playbook, but do not execute. That's a good one as well. -T, and then fill it in with your tags. So -tags equals tags is another format for it. Only run plays and tasks tagged with these values. And then -v, also -verbose, which is verbose mode. And you can increase the verbosity by adding more v's. All right, so the scope of Playbook. The scope of what devices to run a playbook against is included in the playbook itself, but can be overridden using the dash dash limit option. This is useful if the playbook is configured, for example, to run against the entire campus, but there are only changes for a single device or subset of devices. Use the dash dash limit option and provide a group or hostname from the hosts.ini file to specify which devices to run the playbook against at runtime. Ansible-playbook. So here we go. Playbook.yaml dash dash limit host slash group. There we go. That's for the scope of the playbook. Next section is on check mode. Check mode can be used to dry run Ansible playbooks and as part of the change management process. This is a validation step before pull requests are approved. The output from check mode can be made a mandatory artifact. The results from check mode show exactly what devices will be changed and the exact configuration commands that will be executed and in what order. Check mode is often combined with a level of verbosity to display more details about what the Ansible playbook would have changed, as opposed to simply indicating a change. This data is a goldmine of information that can be used to help the NetDevOps team collaborate and fully understand a change before it is deployed. Check mode. So here we go. Ansible-playbook, feed in your playbook, and then dash dash check. All right, and now it's item potency. Much like check mode, the state of playbook item potency is another source of non-technical information NetDevOps can leverage. An understanding of how far ahead or behind either the source of truth or the production network is from each other becomes very clear using check mode capabilities. Once item potency is achieved, be sure no out-of-band changes are made. I don't know what they mean by that. Usually an out-of-band change is like through the console port. So only automated changes using the automation engine. Okay, so they're redefining what a band is here. My understanding of a band was like the almost like you can think of it like the cables. So like, do you get into the device through the same cables that you would pass the production traffic on, or do you get into the device to manage it using separate cables? So like I would think of out of band management access to the device as something occurring over like a console cable, where like the production network traffic isn't going to go over. It's not even fast enough for it to go over. And then like in band, now you're sharing the same bandwidth that you would use for production traffic. So like that's why it's in band, because it's in the same like band as the network traffic. So like now he's redefining it. It looks like he's saying that an out of band change is a change that does not occur using the automation engine and the NDLC process. So we're saying to make sure not to do that, and the branching strategy is followed to maintain the idempotent state. All right, so modern development toolkit. To maximize efficiency, continue building a development toolkit system used for everyday development of Ansible playbooks. Either build a Linux-based system with Microsoft VS Code installed, or a Windows-based system with Linux installed. So I'm building a Linux-based system. I do have VS Code installed. As to whether or not I'll use it, we will see. But as is in my lab environment, I have VS Code installed. I don't have it installed just on my home computer, but here it is in the lab. All right. So, yep. So either way, have a system that includes a flavor of Linux. We got it. It's Ubuntu. Um, Ansible. We got that too. Let's take a look. There we go. We got version 251. All right. So then we need Git. We'll take a look at that as well. So I'll do Git status. There we go. We've got Git. So the next one will be VS Code. Yep, we're already running that. We can see that. Now we need connectivity to TFS through ports 8080 and 8443. We don't necessarily have that yet. So that's going to be an issue. And then the other thing, we don't have connectivity to network devices management IPs via SSH. We don't have that either. Okay, well, I mean, we can set it up. So as far as the TFS, I'm not sure how to set that up. That might be kind of an issue. I'm just gonna make things easier on myself, and I think I'm going to create like an out-of-band management network. I mean, in the real world, it's good to have that anyway. So, it's taking advantage of the fact that I'm in a lab. This is kind of more complicated than I might have it seem, but let's just do that. So we're gonna take just a switch, even just like a hub, Ethernet hub, and then we're just gonna cable up each device into the hub on the management ports. And before we do that, let's load up this hub with ports. I'm pretty sure I'm going to run out of ports. I'm pretty sure the 8 ports that are default on the hub are not going to be enough. So I need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I need at least 15 ports. I've only got 8, so let's give it 20 just so we got some extras. Alright, and now let's cable up the hub. So we'll cable the automation server into the hub. Alright, and now we'll cable all the devices into the hub. And this is not at all what it'll look like in the real world. Now, you might have something like this locally, like for example, you could have like a console server in each of these spaces, and then you could have like the console server be like accessible through online. So you can have this sort of thing in the real world for sure, but it just won't look like this. All right, so I think I got everything. I'm still in cabling mode. And I got really lucky with having management ports. Okay. All right. All right, so yeah, that's pretty good. It looks like a freaking monster. It does not look very pretty, but hopefully it'll get the job done for just being able to access each of these devices from the automation server. Um, I do need to do some actual like configuration. One thing that I could do is just set up a DHCP server on one of these devices. I think it's probably pretty easy to do it on like one of like this Cisco Core device. It should be pretty easy to do it on. So let me actually try to do that quick because it should be pretty easy. All right, and I'll be able to tell which port this is pretty easily because it should get like a lot of ARPs registering. Oh, they're all in shutdown state. We gotta fix that. All right, so it's port 3. I can see that there. So let's bring that up. No shut. There we go. So hopefully that comes up. Yep, I see it there. Okay, that came up. So let's do a show IP ARP. Okay, maybe it's because the other ones are in shutdown state as well. I'm not sure what's going on. We can always tap the link as well. Let's tap this link here. Now it's a hub, so we'll see all the ARP traffic because ARP is broadcast. So we've got CDP. It's coming from. So we don't really have a lot of. Oh, so okay. It looks like our extreme device, and this is extreme discovery protocol, like how CDP is Cisco Discovery Protocol. Oh, we have some DHCP discovers. We don't have. Do we have any offers? Nope, we just have this discovers. So we have some interfaces on our network that are asking for IP addresses, but we don't have a DHCP server set up yet. So let's take care of that. IP DHCP, and then question mark server. Okay, question mark again. Then the oh, let's go into IP DHCP space. Basically, like I want to make this a server. So IP DHCP pool. We're gonna call it OB auto management, and then we'll say oh, I haven't done this in a while. We're gonna say subnet, I think it is. I mean, we don't even need like a default router or anything like that. So let's do subnet, or let's do network, and then we'll feed it like 10. Let's feed it like 172 private space. So 172.16.0.0/24. Oh, it's Cisco land, so it's probably got to be like this, written out all the way. That's typically not the case in other network gear. You can usually use the CIDR, CIDR notation. All right, so that looks good. We don't have to exclude anything. We don't need a default router. We're just gonna stay on our own LAN here. Yeah, I think we're good to go. Yeah, I think we're good to go. So now it's IP DHCP server, and then we need to give a name, or an IP address. So I probably do need to add an IP address on. So let's give it this. Let's do 172.16.0.1. Let's do a IP DHCP excluded address, and then we'll exclude 172.16.0.1. All right, and then we'll go on the interface GI0/3. There we go, and then IP address 172.16.0.1/24. And it's already no shut, but sometimes I just like to do it again. Okay, and we are sniffing this link still, so aha! So now we've got a Dora Discover Offer Request Acknowledge. So it looks like we handed out .2. Oh, we offered. Oh yeah, we're so this is who it's communicating with. It's communicating with the broadcast. So the broadcast finds the server here .1. The server offers up .4. Then the device that wants .4 says yes, that looks good. Give it to me. So the server says, okay, here it is. It's yours. So we've got a .4 on the network somewhere. Let's ping it. What the heck? Oh, I thought we had a .4. Looks like we've also got a .6. This Dora happened again. I don't see where it happened though. I'm surprised that I wasn't able to. Oh, you know what happened? I didn't specify the source address, so IP route. I think it probably has to do with that. If I do source 172.16.0.1. Was that what happened? No, it would have used that as a source by default. Sometimes that can be tricky, which it automatically uses as a source. So it's better to just specify it, but that's the source it would be using. So why? Okay, now we've got ARPs. I'm so confused. 172.16.0.1 is me, so we'll ping. .2 is another device that pings. .4 is another device. But even though that is what's really confusing me. All right, and then does .6. Nothing on .6 either. I mean, yeah, I don't know. I'll investigate that. It's really not important right now. So I can stop the capture, close the Wireshark. And let's see if this got assigned one, because that's important. I want this to be assigned. Yeah, so it looks like this is connected. Let's see what the settings are. It's connected. Okay, so this does have .2. So we should be able to ping out to .1, which is our server. So ping 172.16. Oops, don't have my something's going on there. Ping 172.16.0.1. There we go. It looks good to me. Okay, so we have access to one of the devices. Now we did see that we had .4, so we'll try that. Okay, so similarly, that is so weird. I don't understand why it can complete like it can get a DHCP reservation, but it can't ping it. And the thing is like there's like it handed out, 7 addresses there. But like even though it has an address handed out and assigned to a link, it can't ping it. That's so weird. That's interesting. Huh. I'll have to think about that more. But anyway, let's keep reading. So yep, we have all that. We tried to get this set up, but nothing. And then we're gonna have to work on this later. But so here's the modern network development lifestyle, also known as NDLC. That just stands for network development lifecycle, which is not necessarily modern. It can be any sort of network development lifestyle. It can even describe like a broken one. But the modern NDLC is described here. With new tools comes new processes and procedures. Below is a high-level overview of the modern NDLC using all the tools introduced above. This includes a simple branching strategy. The organization should decide on its own branching strategy. For example, a new branch for every change, no long-lived branches, no branching beyond 2 branches. For now, we will adopt a new branch per change approach with 1 level of branching. Okay, so now this is not a lab exercise here. This is just a description of how a network development lifecycle would look like once all of this is set up and implemented. So the first thing that would happen is you would create a repository specific to the environment in TFS. So I'm not going to do all this because I want to be walked through it. I don't want to spend a lot of time on mistakes here when this isn't the goal of what we're reading. So examples include production, lab, and development. The next thing you would do is create a master branch. The master branch will be what is considered tested, approved, current golden configurations and code. Never develop or make changes directly inside the master branch. Use git commits and pull requests to merge changes into the master branch. Playbook should be executed from the master branch. So the next thing you would do after you have your master branch is to create a working branch. All changes performed in the working branch. So you just, once everything's good to go, you can put it in your master branch. Your master branch is basically for record keeping, where you do all your development is in a working branch. You don't do any active development in master branch. It's kind of like an archive. It's your lockdown source of truth that will never be modified. That's what it is. You make all your modifications in a working branch. So the playbook is tested and validated, possibly with check mode and verbosity. The changes are understood. Commits from local repository made often to ensure TFS version updates often. Prevents local work from being lost. Ensures ability to collaborate on branches. So that's for changes from the local repository. Yeah, so commits from local repository made often. So you have to. So this is what they were talking about, where you don't make, you don't spend the whole day and then commit at the end of the day. You do something that is progress, and then you commit that. As you make incremental progress in small steps. So commits from local repository, so made often, so frequent incremental progress as you're working, to ensure TFS version updates often. And the reason you would do that is because it prevents local work from being lost, and it ensures ability to collaborate on branches. You can think of it like a math problem, like when they say show your work for like an algebraic math problem, they want to see, it's kind of the same thing, why the changes need to be frequent. It's like to show your work, and not just to give a solution for people to be kind of lost at how you arrive there. So the next thing you do in your working branch after you've created it is a pull request to merge branches into the master branch when you're finished with your development. And you do this because an entire workflow can be created from the pull request. Various quality control and approvals can be implemented before it's just automatically there. So you can kind of safeguard your master branch that way, and it's not vulnerable to mistakes. And then changes, so and then you're only adding to your master branch changes that merge successfully into the master branch, and you make sure that this is like, a lockdown perfect place that is not vulnerable to any mistakes. If you make any mistakes, those sorts of things, they happen in the working branch, and then they're caught by various QA and approvals. Kind of like the whole spirit of this channel, where you're making your mistakes less impactful. You're doing them in the working branch, and then anything that goes in the master branch, at the time it was put in the master branch, was mistake free by all the best efforts of the organization. I would say, so now the next part of the NDLC, after you've created a working branch, and you've merged it into the master branch, is you clone the repository locally using git clone. So this brings the repository down to a local Windows or Linux machine. Mic check. Okay, good. It's extremely portable, provided Linux and Ansible are installed. Okay, and then you would change in your local files, local repository, to the working branch. So git checkout VS Code GUI to change into new working branch. Then you would make all your changes, modify the existing files, create the new files, delete files. Then you would you would stage your changes using git add. You can also use the VS Code GUI to save local changes, which I find is like pretty good. Then after that, you commit your changes. You can either use git commit at the CLI. You can use the VS Code GUI. Make sure to add meaningful comments to each commit. The commit is referenced and available in TFS and VS Code, and you can reference it on the command line as well. You can do git log, and if you do -- one line, ONELINE, it's nice and readable. You can see all the commit hashes and all the commit messages. All right, so then you push the changes using git push or VS Code synchronization, and this finalizes the commit and pushes the files to the central repository. And that now you create a pull request. A pull request in TFS is created to merge the working branch into the master branch. A full workflow can accompany this pull request that could require reviewers and approvals. And then finally, version control and change control. All changes can be referred to by their pull request. Each pull request is comprised of git commits. Complete history of changes to all files are available through TFS. So there's easy rollbacks, and it's easy to troubleshoot problematic changes. So that's the full thing that's being introduced in this book that you would not have been able to do before. All right, I'm going to take a quick break. All right, I'm back. I want to close this out really fast, so let's keep reading. Let's see how much more we've got to close out Chapter 2. It looks like we got quite a bit. Actually, no. It looks like we just got a lot of graphics, and then we can close out Chapter 3, I mean. So yeah, let's close out Chapter 3. Let's do it. All right, so the next section is Microsoft TFS Central Repository features, which we don't have. We have Azure, or we could use GitLab if we want something open source, or Jenkins. So Microsoft TFS is much more than a centralized repository for code. It is a full development ecosystem enabling cross-team collaboration as well as version and source control. TFS also acts as a GUI for Git and automates software builds, testing, and releases. Work items can be assigned, tracked, and used to create working branches for new code. Work items should have limited scope, such as new feature, request, bug fix, or enhancement to code. New items can be added by anyone with correct permissions and can be directly assigned to individuals or left open for developers to take ownership themselves. Working branches, sometimes called feature branches and bug fix branches, can and should be created for every work item and change made to the repository and therefore the network. And changes committed often to these working branches. So developers can collaborate using the CI continuous integration module. So here we go, creating a new branch in TFS. There we go. The central, so like for me, I'm using GitHub for that. So like, you know, this is where it gets confusing. Is like, where are we creating the branch? So there's two places you could create the branch. You can create the branch in the centralized repository. So that's in TFS in this case. In my case, it would be in GitLab. Or you can create it on your local machine. So that's why it can be confusing. So the central repositories can be explored through the browser, including the complete history of every element of code, all the current and previous branches and pull requests, including the related Git commands. TFS history is a rich source of information and an easy way to explore the changes made to the network. Troubleshooting problems becomes infinitely easier now that changes can be viewed in reverse sequence of application. Problems can be pinpointed to an exact pull request as well as the commit involved in making the change. All right, so yeah, so now we can go through all of these changes, see them in a nice side-by-side diff, and narrow it down exactly to where something went wrong. So each of these branch updates can be expanded for a summary of commits on this branch. Okay, so this is somebody who worked on the network. It looks like AYN merged that in. So here's all the work they did. They changed something on the campus. They fixed the default gateway and changed all the documentation. Or sorry, they changed the default native VLAN. I'm not sure why this word default is in there. That makes it kind of confusing. They changed the native VLAN is what they did. So the branches view provide a detailed view of the master branch, all working branches and their relative state. Branches can be ahead or behind the master branch, and the details of what code in which files is different can be determined using the branches view. So, okay, so here's the branches view. Completed or pending pull requests along with their commit history can be explored. Pull branches can be initiated to merge a working branch into a master branch, merge a working branch into another working branch, merge the master branch into a working branch, possibly to refresh an older branch or bring a working branch up to parity. Alright, so completed pull requests can be viewed along with the changes that were merged into the master branch. There we go. So in summary, network automation is more than just a set of new tools and technologies. It includes adopting a modern network development lifestyle, or life cycle. The network needs to be prepared for the necessary communication flows between the tools and the environment. Several new technologies, including Microsoft Team Foundation Server, Microsoft Visual Studio Code, Git, Linux, and Ansible, need to be installed. Once established, the network automation ecosystem allows you to begin the next steps to complete network automation. Chapter 4 is a guide for the first steps to using the new network automation system. Alright, so that's the end of Chapter 3. Thanks for watching and stay tuned for Chapter 4.